of the Department of Family Medicine and Community Health. I also sit on the Wellness Committee for the University of Miami, and part of this week's, I see you all have green bags, part of this week is kind of trying to help everybody get on board with the idea of wellness and prevention. So today we have the great privilege, and I mean great privilege, of having Colin Campbell with us. He is an icon in this country regarding nutrition, and he's going to talk with us about the work that he's done. I had a chance to review his curriculum vitae, and after I got to publication number 300, I stopped and I said, there's no way that I can do justice to his very long career in nutrition. He trained initially at Penn State and did his master's and doctoral degree at Cornell, and is still there as a professor emeritus. If you haven't seen Forks Over Knives, I encourage you definitely to see it. Certainly it has made a great impact on me. As a matter of fact, I saw another film the other night called Earthlings. If you haven't seen that one, I encourage you to do it. It's all about how we treat animals in this country. Dr. Campbell has a really outstanding career, probably more than 40 years. Is that right, Dr. Campbell? 50 years of experience, and I welcome him today to help us focus on our diets, what we're eating, what we're putting into our mouths, and the impact it has on all of our health. Dr. Campbell.
Thank you very much. Let's take a minute here to put this on. Sorry for that noise. I guess you can hear me okay, right? Yes. Great. Tuck this in my belt. Well, thank you, Dr. Swartz, for that very kind invitation. It's really a pleasure to be here to talk to you about a topic that I've spent so many years focusing on myself. Is basically deciding what do you put in your mouth in order to stay well. My career has, of course, been in nutritional science for the most part. And although I spent some early part of my career working on the etiology of cancer as well. In fact, it was my interest in cancer primarily that got me into the question concerning the possible relationship between food and cancer, for starters, but then that expanded quite broadly. What I have come to now believe these days is almost diametrically opposed to what I started out with in the early part of my career. In two ways, actually, both personally, as far as what our family was eating at the time, as well as professionally, in both cases. And then there was another part too, where I was trained in science. I have been a biomedical researcher all these years, and I have been taught to think like a scientist, working in depth and with precision and all that on one thing at a time. And that was another sort of background where, in fact, I shifted gears. So this story now is so big, it's so broad, it has so many implications, all the way from our personal health that hasn't been well recognized, to be honest about it, all the way from our personal health to this health of our society, if you will, as well as to sort of global issues, even planetary conditions. I mean, this story keeps on going on and on in respect to what we choose to eat. It's really a big topic. Now, am I getting a feedback here? Is this working okay? Maybe I should get away from that. Probably that right there. In any case, there's so many ways to talk about this subject, and I've tried different ways. I think the best way, at least from my perspective, is because I don't like to preach and I don't like to proselytize, I just simply like to offer the information for your own consideration. And so with that in mind, the way I sort of like to do it to try to capture some of the things that actually influenced me is to tell you my story, in a sense, a little bit of the chronology of how the kind of research that we did, the kind of results we got, and then let you decide for yourself. And of course, so this is just hopefully an opportunity for you to at least raise the level of discussion, if you will. So, as I say, I started out in a place different from where I am now. I'm not on a farm anymore, not driving a combine. That's me right there. As I like to say, maybe 7 or 8 years ago or so. In any case, after leaving the farm, milking cows, going away to graduate school, I got into a program that was in so-called animal nutrition, trying to understand nutrition, if you will. And in fact, that was my thesis there, where the effort was being made actually to promote the consumption of more protein, especially the consumption of more animal-based protein, because animal-based protein was considered to be high quality. And of all the things in our food that, from a nutritional perspective, that seems to gain attention over the years has been protein. I mean, we almost revere that question concerning the value of protein, and we have tended over the many, many years to actually encourage the more protein, the better. And of course, we also like to think we're getting the highest quality protein too, which in fact sort of gets us into the territory of consuming animal-based protein. So there's where I was, both from the farm, milking cows, producing milk because of its value of protein, and then into graduate school. And then I got to continue on with that a little bit when I was at Virginia Tech in the 1960s, where with my senior colleague and I, we were invited to go to the Philippines and actually put together a nationwide program of feeding malnourished children. Malnourished children, of course, was a problem in those days, still is obviously for many countries and poor countries. And we tended to think about malnourishment in children with respect to two nutritional considerations. First off, malnourishment can occur because children aren't getting enough calories. We have a name for that. It's called marasmus. The other is that they don't get enough protein, in which case we call that kwashiorkor. So malnourished children, two things, enough calories, enough protein. It was the protein part of that equation that when we went there was to make sure that these kids got enough protein, because in general in the Philippines, a poor country in those days, in general the level of protein consumption in the Philippines was only about 2/3 of what we get here, really substantially lower. And we thought that could be a big problem. So in any case, we were dealing with that problem, building so-called mother calf centers around the country to figure out a way so that these children could get better nutrition. It was one day, however, when I was actually playing golf with my colleague, who was in fact a surgeon. He was a medical advisor to the president of the country at the time. And he told me how he and some of his fellow surgeons had been operating on some children aged 4 years of age and younger with primary liver cancer. And that was, I mean, it was fatal. It wasn't, they weren't successful with these operations, of course. But what was odd about that really was the fact that these young children were getting primary liver cancer. And I had this interest in cancer etiology too, and I knew enough to know that primary liver cancer tends to occur in the middle of the older age people, not children. So that was an oddball thing. I didn't pay a lot of attention to it, but it's, you know, you kind of remember these things. Because of the other hat that I was wearing at the time, and with my colleague, we were interested in finding how much protein really was being considered, going to families, you know, collecting survey information and things like that. And I sort of picked up this idea, totally anecdotal, wasn't published, that somehow the families, the few families who were consuming the most proteins, or like we do in the West, and they were rather small in number, but the few families who were consuming the most protein, in a sense, I just got the impression, that's all I can say, I got the impression that those were the families that were actually having the children more likely to get the primary liver cancer. So in other words, primary liver cancer occurring in the richer families, if you will. And for those of you, I'm sure, who know this history somewhat, hepatitis B virus at that time had not yet been discovered. So that's a part of the story I'm not going to talk about here in this lecture. But we didn't know about that, so all I was seeing was that higher protein, higher cancer in these kids. Then there was this publication here that came out from India. in which case what these investigators wanted to do, they wanted to study the etiology of liver cancer, the histopathological characteristics of liver cancer in animals was rather similar to what we see in humans, and so they thought it was a good model. So what they were doing here in this particular case, they had this idea that primary liver cancer might be more common when people were not consuming enough protein. In other words, they were arguing that, you know, liver cancer could be a protein deficiency disease to some extent. So they did a study. They put animals on two different levels of protein, 5% of total energy and 20% of total energy, 20% being generally recognized as the ideal, or the ideal, the regular, the recommended, if you will. And so these animals then had been exposed to a carcinogen. It was aflatoxin, for those of you who may know about that chemical carcinogen. They were exposed to aflatoxin, then fed these two different diets. Aflatoxin is a potent carcinogen for causing liver cancer in rats. In any case, they gave them two different levels of protein, 5 and 20%. They thought that the 5% animals would show much more cancer. They get equal amounts of exposure to the carcinogen. And so you can see here, it was exactly the opposite. The animals given the higher levels of protein, they were the ones, 100% either getting the tumors or at least pre-neoplastic, hyperplastic nodules that were to lead on to carcinogenesis. And as I said, it was exactly the opposite. As a matter of fact, these investigators didn't believe that, because in those days, protein was so valuable. How could that be? That's silly. You know, protein causing more cancer. And so they went back and did a study a different way in which they used a different dose of the carcinogen, very high dose, and they ended up looking at acute toxicity, not carcinogenesis. And that's what they wanted to believe, because in that particular case, higher protein would have protect against acute toxicity. But that's a sidebar story. I don't want to go down that track. The point is that they didn't really believe their own data, and they didn't really take that too seriously until I was invited over about 25 years after that, in which case I was discussing with them our results, that in fact it looks like what they were saying here was correct. It had chosen the wrong results. So in any case, this, together with the observation of the children, you know, these are not robust data, not really strong findings, but it's enough for me to get an NIH grant that then was to continue for the next 27 years. And we did lots and lots of research on this because I wanted to know, first off, is it really true that protein turns on this cancer? That's number one. And number two, in a sense, I wanted to learn what the mechanism was. I mean, it's a provocative idea. And so we'd like to know, and I'm sure if all of you, of course, in medicine, you recognize this, when we can know something about how these things work, it gives us a lot more confidence in what we're actually seeing. So I wanted to know how it worked. So what I want to share with you here are just a few things that we sort of learned along the way. And as I got involved in this research, this was not a matter of determining, you know, is this carcinogenic or that carcinogenic. What I was really interested in doing was to actually learn something about the principles of how nutrition works. I mean, in textbooks in those days, and the way we taught it, and I was teaching upper-level nutrition myself, we had certain principles we abided by and sort of assumed and accepted. But as we got into this research, it turned out that we kept seeing things that others would call heresy. And we occasionally get results that simply weren't told and weren't believed. And so I kind of had to live with this idea of discovering one heresy after another. When finally, as you'll see, it came to a point where all these heresies, when you think about them, all of a sudden it was beginning to describe a whole different worldview, a different paradigm, that I then ended up calling my heresies principles or lessons. I'm going to show you here just a few slides going through what I mean by that. And what are some of the lessons that we learned along the way? And I could show these many different ways, but let me just, I've just made a selection of some of them that didn't make my point. Namely, when we took animals, experimental rats in this particular case, and we exposed them to the carcinogen and the bacteria to cause the mutation, if you will. We call it genetic initiation. Cause the mutation. That's the aflatoxin. We know quite a bit about now how that works. We knew something in those days, learned about that. But anyhow, we initiated the cancer here. And then for the first 12 weeks, as these early cancers were forming in the form of pre-neoplastic lesions, in a sense, we could see what effect the dietary protein had on the development of these early cancers. And you can see that 20% protein animals, they were developing rather nicely. It's very clear. The animals getting to 5%, no growth, in spite of the fact they've been exposed to a carcinogen. And of course, this is equivalent to what the Indian workers had done. It was also equivalent to what, in fact, I thought I was seeing with these children. So then we went beyond that and did some various and sundry things to try to illustrate this a little bit better. And here's one of the things we did. We wanted to just simply switch the 5 and 20% diets back and forth again. And you can see here it's really quite clear. The animals fed the 20% diets. They're on that track right there. If they switched to 5, it was turned off. Back to 20, turn it on and off. That was really pretty remarkable. It was remarkable in the sense that here we were turning on this cancer. It was very responsive to the intake of nothing more than a nutrient, and of all things, protein, if you will. So that was an exciting idea, and that, in fact, led to, as I look at it in retrospect, to lesson number 1, namely nutrition controls cancer growth. That was, as I say, that was heresy, really, truly was heresy, and I think for a lot of people, even today, they still want to think of it as heresy, that nutrition can do that. But in this particular case, it was one protein, of course, controlling it. That was an exciting proposition because in those days, and still these days, we tend to think of cancer in a very general way, being caused by genes, your genetic background, or caused by viruses, or caused by maybe chemical carcinogens, or mutagens. Here is something different. We're talking about simply adjusting nutrient intake to cause that disease to go its way. Okay, so that's lesson number 1. Here's another sort of lesson in a sense. This is a schematic of several studies that we did. Oh, my apologies. This happens more than oh my gosh, sorry about that. Sometimes I just leave it on and say, just listen to my lecture and I'll talk to you later. But anyhow, my apologies. So here's a schematic concerning the question of the relationship between, let's say, nutrition and genes. With the notion that, cancer is caused by genes, all start with genes. And so here is normal cells, if you will. Here's a bunch of cells here, some of which had been mutated, if we can look at it that way, mutated to create, let's call them cancer seeds. They were mutated to a form. They don't get repaired. They're in a position now to grow into cancer cells. Over here, we got the schematic showing, not very many mutated cells. And if the diet remains the same from here down, surely the ones that have started the most seeds, more tumors. It's very clear. That's the dose-response relationship between a carcinogen and the tumor outcome. So this leads us to the idea, genes cause cancer. Well, let's have another look at this because it turns out that when we do the experiment again, and the ones starting with the most seeds, given the low protein diet, they're the ones that essentially get less than almost no tumors. The ones getting just a few seeds at the beginning, put on the high protein diet, they get more tumors. This enabled us to think about the question concerning the relationship between nutrition and genes. Everything in pathology and physiology, I'm sure you recognize, everything that we think about in this context, it all starts with a genetic basis. We know that. I mean, the DNA is our template, our blueprint, if you will, and so everything springs from our genetic basis. So in that sense, we can say, this is caused by genes. Yes, that's true. But in reality, it turns out that the effect of those genes on whatever we happen to get concerns the expression of the genes. The expression of the genes, in this case, that's where nutrition comes into play. It's a powerful force, and it hasn't been recognized that way in my view. Nutrition controls the expression of genes. Okay, so then the next question, if you accept that idea, then you can think about what kind of nutrition, which kind of genes. You can get into all kinds of interesting things that we got involved in over the years. What's going on here? Okay, so that's one question. Nutrition controls genes. So now I want to show you the second question, something about the second question that has to do with what is the mechanism accounting for this effect? We're looking for the mechanism. So this is so provocative. And I'm just displaying here actually a scheme progression over time for the development of cancer. we've become accustomed to talking about it this way. Cancer starts out as an initiated event, where the carcinogen causes a mutation. A lot of that gets repaired, but some of it escapes and goes on to the next generation of cells. So here's initiation. Here's this long period here of promotion, which theoretically, in the case of humans, may take years as the cancers just gradually develop over time. And finally, here's the more dangerous part, the progression when it's been diagnosed. So we got involved in seeing if we could find the mechanism that through which this protein acted. I don't know whether I got something. It's not. I'm going to have to. Not a strong battery, I think. What's gotten ahead of my talk here a little bit, but in any case, let me just say this. As we look for the mechanism during the early stages, every time we looked for the explanatory mechanism, we found one. For example, this enzyme system here in the liver activates chemical carcinogens, the mutagens, to give rise to an active metabolite that then binds the DNA or the genes to initiate the whole lesion. I mean, that's pretty well accepted by most people these days. But that was increased. That enzyme was increased in its activity in many different ways by higher protein diet. So, that's it. That's where this all goes to. But then we started looking around. Then DNA binding, the level of DNA binding, which reflects both the synthesis or the occurrence of DNA bound adducts, if you will, the level is both a function of the rate at which it forms and the rate at which it gets repaired. And it turns out higher protein diets increased DNA binding, and several mechanisms associated with that. Carcinogen cell transport into the cell. We looked at that. And sure enough, the higher protein diets would enhance and encourage the transport of the carcinogen into the cell. The altered MFO structure was another fascinating thing. This mixed function oxidase enzyme is a fascinating enzyme. It has a three-dimensional shape, and its slight changes can change its activity. And it turned out the higher protein diet could change that enzyme structure in such a way, and therefore its activity, in really some fascinating ways. So it turns out that for initiation, we had all these enzymes, all these things. I couldn't put my finger on any one as being the sort of responsible mechanism. So we started looking at promotion. And in this case here, it did things like, decrease natural killer cell activity, an immune response that's responsible for kind of dissipating or clearing up cancer cells. High protein diets diminished the ability of the body to get rid of the cells that are being formed. It increased cell replication, oxidative activity, the insulin-like growth factor. I think we were the first to show the relationship between insulin-like growth factor as a sort of indication of cancer development. Altered energy. Here's my point. I don't want to get into all these details here. Finally, each one of those usually took one graduate student 3 or 4 years to work on, sometimes more than one. So I burned up quite a lot of graduate students, as we sort of looked for these mechanisms. But it turned out that there came a time when, we couldn't just finger which one of these really mattered. When it suddenly occurred to me, that's not the way it works. It turns out, and now I can say with a great deal of confidence, looking at other nutrients, other disease conditions, that nutrition does not operate by one nutrient going in and doing something to cause an end result. It turns out that even in just one case here, just one protein, just one nutrient, when it's doing its business, everything seems to go wrong. It's almost like a tsunami of mechanisms working together to create the response. And if you stop and think about it, that's really a pretty remarkable thing about nutrition, which tends to set it apart from classical sort of cause and effect kinds of relationships, if you will, especially when you think about the use of drugs, which we like to think we understand how it works, and here's the mechanism, here's what it does. We're getting, in other words, just strays from that linear model into a more sort of multifaceted model. So in this particular case, got another lesson out of this. Nutrients act not by one, but by countless mechanisms, as in a symphony, working together. Very important point. This really sets nutrition apart from what we tend to think about when we're thinking about these kinds of things, either in medical research or I would suggest in practice. So, okay, here's another sort of observation that was heretical then, and for a lot of people still today is very heretical. Namely, the protein that we were using was one we could just get our hands on. It was the most convenient one, And we used it that way without thinking too much about it. But it was the same protein that Indian workers had used. It was casein. Casein being the most common protein in cow's milk protein. It makes up about 87% of cow's milk protein. In contrast, soy and wheat protein did not do that even when it was fed at the 20% level. So here's all of a sudden just casein, an animal-based protein, turning on to cancer. The plant-based protein is not. And of course, if you drop the level of the animal protein down to a certain level, you didn't get any effect either. So it was really quite remarkable what casein could do. As a matter of fact, there's another lesson, and this is really a toughie, but I'll tell you what I did with this. Casein is the most relevant chemical carcinogen ever identified. I doubt seriously if anyone in here has really heard too much it being described that way, but it really is. I'm quite familiar with the formal program that our government uses and WHO uses for determining what is a chemical carcinogen and what it's not. In fact, there's 3 laboratories in the world at that time who were concerned with this and making regulations and things. 2 in the United States, 1 FDA, 1 NIH. The third was WHO in Lyon, France. So I took these results at that time, now 25 years ago at least, and brought this information to them and to get their feedback, because it really in many ways really challenges what we think about when we think about what causes cancer, especially chemical carcinogens. There was no fault found really with the research, and the director of the one program in North Carolina, I remember his saying at the end, he said, okay, I accept it, so forth and so on. He said, but you're not going to get anybody to change their minds on this, because he said of the clinical pathologists, experimental pathologists in the country, most of them rely on this assumption, and that's why they do the work they do. He said, you're only going to get someplace if you go to the White House. So I was being taught a lesson, that this, even though this was clear, even though we could agree that it was good research, even though we could agree that the results were good, we're not going to sell that idea to anyone, which I found very troubling, because after all, I think science is something we have to face those things that we may not like to listen to in the beginning and just move on with it. This is the reason I too also showed you I came from a dairy farm milking cows, because here we are milking cows. To the extent I even knew anything about nutrition in those days, not much I can tell you for sure, but maybe a little bit, the extent to which milk was good because it was a good source of animal-based protein. Not animal-based, just a good source of protein. So all of a sudden, seeing my favorite nutrient, I was growing up with, in a sense, having this ability to turn on cancer, that was a pretty exciting idea. Another lesson here, too, can't get into fully defending this proposition, except to say we used other nutrients as well. Namely, nutrients of animal-based foods function differently from nutrients of plant-based foods. A lot of them say, oh, well, that's pretty clear. But let's look at this a little more, because I want to show you something else that really came out of this that was quite exciting. Namely, we wanted to do what we call a dose-response relationship, feeding different levels of casein to animals all fed the carcinogen, and to see which level of protein might actually promote the development of cancer. I was particularly interested to see if it was this kind of relationship here, a very linear kind of relationship, if you will. It turned out it wasn't. It's this hockey stick effect, we call it, with a threshold. In other words, feeding animals 4% protein, 6, 8, and 10% protein. 2 animals have been exposed to a carcinogen. Feeding those levels, no cancer grows. So what that's saying is that protein is an important essential nutrient. It will not cause cancer as long as it's within the level that's doing the right thing. Above this level here, that's when the mischief starts. That's when the carcinogen starts. So and then I have to sort of revise my comments made earlier, namely, it's not just casein causing cancer, it's casein fed above a certain level causing cancer, okay? That hockey stick effect is typical for nutrients studied in my field. Nutrients tend to have a sort of a medium range within which they are operating and doing good things. If it's too low, we have problems. If it's too high, we have problems. I'm sure you can appreciate that. And this is just one end of that. Here's a normal range, and here's where we run into problems. That hockey stick effect then really started to suggest to me that maybe there's more to this than just this simple little rat study by which we did this. It turns out that the level of protein that we humans consume is in this range. 95% of us at least. I'm using NHANES data from the U.S. government on this to make this suggestion. And so we're living in this region here where if in fact what we're seeing in the animal studies, existed for humans, we're living kind of in the danger zone. Because 95% of us are consuming between 11% and 22% approximately, at least in figures I was using at that time. So that raised the question, well, is there still something more here to learn and to have any more meaning than just this case for experimental animals? And I want to just sort of run through some thinking with you on this. Basically, a threshold distinguishes obviously different properties. This is one set of properties here. This is another set of properties here for, in this case, casing. So the next question then, from my perspective, is does this hockey stick effect in any way relate to, let's say, some other nutrients? Or in any way does it relate to, let's say, general health, other kinds of outcomes, heart disease, diabetes, whatever you name it? There's all kinds of things where we're beginning to know that nutrition plays a role in these various and sundry outcomes. And it turns out this is the relationship protein tends to have with outcomes. It's sort of that hockey stick effect. And it turns out also that protein, being a very important good nutrient, is good up until about 10% or so. It's above that level where we begin to see things like cholesterol levels going up. And the effect of casein is more dramatic than saturated fat, for example, in causing cholesterol levels to go up and atherogenesis to begin to form. So here's this sort of same shaped thing. Now, the RDA, I think many of you know what an RDA is. It's the recommended dietary allowance. And the recommended dietary allowance for protein was first set in 1943 by the National Academy of Sciences when they were working on questions concerning the adequacy of the diet for soldiers at that time. And they came up with a figure that was, at that time in 1943, published it, and it's been revisited every 5 years since. It stood the test of time, and it's never been changed. Different scientists looking at different data, new data. That RDA for protein is pretty well established. It's pretty well established, I think you would agree. Because I think it's been 14 times it's been reviewed over all the years since. And so that RDA is a good number, let me say. It's been really pretty well defined. That turns out to be around 9 to 10% of total dietary energy, 9 to 10%. So what that's saying to us, if this relates to various outcomes, what that says to us, we should be consuming protein up to about this level. We ought to be doing okay. Now, a lot of people look at RDA, especially nutritionists and dietitians, they tend to assume this is the bottom number. We need to be in excess of this, especially for protein. So there's sort of the narrative out there is, consuming more protein, we should be consuming up here. And that's the way the history has sort of gone. In reality, this RDA is not the minimum level that a lot of people say it is. It's simply not. The minimum level of protein needed is around 6-7% or so in that territory, around 6%. It's right here, called the minimum daily requirement. And when those experiments are done that way, depending on what your outcome you're measuring, when they're done that way, 6-7% protein is the minimum we need, percent of total calories. In fact, it's probably a little in excess. So they took that number from the experimental situation, added 2 standard deviations to it to make sure it got the larger population. That's where the RDA comes from. So here, let me say it this way. When we're consuming a diet that has, let's say, 9-10% protein, that's in excess of the needs for, let's say, 98% of all of us in theory. And that's what 2 standard deviations really means. So when we're consuming this level of protein, we are getting enough. And 98% of us don't even need that, especially as adults, where we're somewhere down in here. So this sort of puts a very different shape on things when we recognize it that way. So then the question becomes, what kind of food should we be eating to get that level of protein? And what does that mean for the consumption of other nutrients too, and other kinds of outcomes? So let's have a look at that a little bit. It turns out that if you consume just plant-based foods, vegetables, I should say whole plant-based foods, vegetables, grains, legumes, and seeds and so forth, if you're eating a diet of that mixture, that diet on average is going to be somewhere right around here, 9-10%. When we're consuming a plant-based diet, whole food plant-based diet, we're getting all the protein we need, period. That's really what this is actually leading to. And we don't need to consume animal foods just to get the protein. So let's have a look at, and animal-based foods, of course, actually we consume animal-based foods. We consume a lot of it as a society. As a matter of fact, 70% of our total protein intake comes from animal-based foods. We are pretty carnivorous in our eating habits. And so we're consuming a lot of animal-based foods. That, in turn, when you're consuming more animal-based foods to get all that good protein, that displaces the consumption of plant-based foods. So we end up sort of over-consuming, let's say, protein, getting in the danger zone, wrong kind of protein, and in the process, displacing all kinds of other nutrient considerations too. So the ultimate effect of food on health is a combination. It's a combination of different kinds of nutrients, oftentimes leading from this initial idea that protein is so darn important. So here's the difference between plant and animal-based foods from a nutritional perspective, and it's really kind of interesting to look at this way. Antioxidants are almost exclusively found in plant-based foods. At least they're synthesized only in plant-based foods. And of all the nutrient classes, I would suggest that we can find the most interest in is the antioxidants. Because the whole process of us aging in particular, we're always in the process of sort of producing some free radicals and highly oxidizing things, and as we go through life. And in fact, the more oxidation there is, the shorter the life. That's one of the things that occurs. And so high oxidation tends to spur cancer growth. High oxidation tends to sort of erode the plaque in blood vessels, for example, and cause them to burst. And so oxidation is not a good thing. You think about oxidation is nothing more than rusting. Rusting is oxidation. So oxidation is a big deal, and we've got to keep it under control. Well, oxidation tends to occur over here. Animal-based foods is what promotes oxidation, especially when, as we increase animal-based foods or decrease in plant-based foods, we're getting rid of the good things. The antioxidants keep things in check. So here's, in other words, we get the right amount of protein here, and we're getting a generous supply of antioxidants. That's a good deal all across the board. Countless complex carbohydrates also are being consumed from plant-based foods, only made on plant-based foods. We don't get complex carbohydrates in animal-based foods, really. And complex carbohydrates play a major role in gastrointestinal health in particular. Another sort of part of the story that's kind of fascinating. Without getting into the details, I'm going to say also that a plant-based diet has the right amount and kind of fat, around 10%. Okay, so, and over here we've got these issues. Animals don't produce complex carbohydrates, small amount of that. Okay, so now we're looking at food groups and seeing this major difference between plant and animal-based foods. Here's, for example, here's 5 groups of nutrients. Minerals I could have put there too, but I didn't. In any case, you look at these things here. Antioxidants and complex carbohydrates and vitamins, classically speaking, are only made in plants. Now, I know some of you who might be familiar with nutrition will say, wait a minute. There are I can think of a couple of vitamins that are present in animal-based foods. That's where they're produced. I'm thinking of vitamin A and vitamin D. But in reality, according to the classical definition, a vitamin is something we must consume because we can't make it. It turns out we can make vitamin A, we can make vitamin D. It's just a question of, just eating the right way, doing the right thing, we get all we need. Vitamin D is, of course, made in our skin after sunshine exposure. That becomes a hormone. It's not even a vitamin. Vitamin A, as it was originally defined, is retinol or retinal or retinoic acid. Those derivatives of vitamin A, that's considered vitamin A. It's rich in liver. We used to eat liver a lot to get the vitamin A, all that sort of stuff. Actually, we can make all we need of the retinol derivatives that we call vitamin A if we consume enough of the precursor. That's beta-carotene and the carotenoids. So the real vitamin for vitamin A is really the stuff in plants, not in animals. So that's why I put that there. So here's 3 important nutrient groups that are really, really important. In addition, now the fat and protein too. You can see a typical plant-based diet is going to have somewhere in this area here percent of calories of fat and protein. That's what we saw from the previous sort of analysis. Somewhere right there. Animal-based foods, they don't have the good stuff here, and they have too high levels of protein and fat. So you add this up. You just start adding all these things up. It's enormous. It's enormous when we start looking at the data in this sort of fashion. Big difference, plant, animal-based foods in that sense. There's a third sort of food group, that's the mischief that we have to think about, and that's the so-called processed foods. Becoming particularly prominent, I would say, since the Second World War, with marketing and all that stuff. Processed foods actually can be all plant-based parts. We can have, but that's not what I'm talking about. They can have some refined carbohydrates. Let's say you can get some sugar, maybe get some white flour, get some of that good oil from plants, the polyunsaturated fatty acids. You put all that together and you get a donut or a pastry. And of course, that's not the whole food plant-based diet or food that I'm talking about. So processed foods often tend to be high in fat, high in sugar. It's sort of a hedonistic kind of marketing tool to get us to eat the things that we become addicted to. So what I'm going to suggest, this is a third food group, if we will, processed foods, that are not really good. Really not good, because when you take those kinds of things out of plants and you move over here, then you're not taking along the complex carbohydrates, you're not taking along all the antioxidants, you get the wrong level of protein, et cetera, et cetera, et cetera. So what I say, we have three groups of foods: animal, processed, and plant. Now I can spend the rest of my life and all that. We can spend all kinds of time talking about the hazards of consuming processed foods or animal-based foods, even though there are lots of problems. That's one approach to take when you're talking about nutrition. The other approach, I don't like to talk about negative things all day long, because there's something here that's really positive, and it has to do with plant-based foods. When we talk about it that way, we can begin describing things that really work, and they're amazing what they can do when you do it the right way. So that's my preference, is to focus the discussion on whole plant-based foods, not on these two mischief groups that, obviously we have problems with. So, but finally, from my perspective, we had to go and think more than just about protein and other things. We worked on fat and pancreatic cancer and just the protein and liver cancer. We worked on fat and mammary cancer and did things like this. And so we explored different things. We got into cholesterol and heart disease and looking at these same relationships in a sense. And all of a sudden it was coming together like this in terms of whole plant-based foods. That was the result of asking questions having to do with other nutrients, other diseases, and of course, especially nutrient-nutrient interactions. That's a ton of complexity right there that one has to understand. And it was about this time, now already 25 years ago, 30 years ago, that I had the opportunity of doing a study in China with my colleagues from China. This was the first project between the United States and China. It was funded by NIH, and actually we did it in collaboration with the University of Oxford, where I also have a position that it did at that time. So we had three institutions involved in this. What we wanted to do in China was that at the early 1980s, the Chinese were reporting a study they had done in the 70s showing how much cancer existed for a total of about 2,400 counties around the country. And they reported these data here in the form of these color-coded atlases. It was rather nice. And you can see here, for this being breast cancer, you can see that cancer, without seeing those color-coded there, you can see that cancer tended to be quite high in some places, much lower in other places. Cancer was geographically localized. It was just here, not there kind of thing. Big difference between these different regions in China. And so we did a study there, and we learned, of course, that 94% of all the people that we surveyed, there was a total of 130 villages, were actually still living in the counties where they were born. So it was a very stable population group in rural China, where we had a chance to go and sort of ask this question. The Chinese, the British, and myself, we asked the question, what's causing this? Is there something nutritionally involved here that might sort of help to explain some things? So we did this study. We measured lots of different things. Okay, we ended up with 367 variables, I say. That was about 4 dozen different kinds of disease rates, not just the cancers, but also heart disease, and what the Chinese had by way of causes of death, as they called it. We can then take this and organize all this in the form of correlations, and then begin to look for patterns. Correlations don't cause causality, in case of any of you are concerned about that's not the way we did it. Anyhow, we had this mammoth amount of information, so we ended up looking at the investigation of patterns, patterns, in which case then you can ask questions from a research point of view or an analytical point of view. You can ask for the odds of seeing certain things in the way of patterns. It's one way to begin to look at complex information. It's not, as I say, it's not individual correlations. So we ended up looking at some models of breast cancer and liver cancer and energy utilization, Western disease, and so forth. We'd look at a model. We had lots of things to measure about a particular outcome model. And we wanted to see if all the things we measured, if there was any convergence of information that might come together to make sense to actually account for, let's say, a high risk of these diseases. And so this was the conclusion that we did with much of the early stuff that was published. Within explanatory models, statistically significant majority of correlations favored less disease for nutrient composition of plant-based diets. It's the nutrient composition of food that best predicts its effect on health. Nutrient composition, a combination of nutrients that are working that does that better than any other way I know. Put it in practical information, consuming a whole food, plant-based diet, whole foods, less total protein, fat, no animal protein, less chronic degenerative disease, and it's consistent with the animal studies that we had been doing up to that particular point in time. I do have to say one thing here in case any of you know about this. We did not hinge, I am not hinging my argument on the basis of the China study alone, period. The China study was simply sort of a fascinating study in humans, very unique, I should say, to see if in fact the results that we got was consistent with what in fact we and others had found in the laboratory. So the China study itself was exciting, unique, different, but the results that we got, in fact, was pretty nicely correlated with the others. So by this time, I'm saying, okay, I give up, more or less. We had enough evidence, from my perspective, that although having been raised on a farm, eating animal foods and all that kind of stuff, we gradually in our own family started to change, and it really became quite interesting. But finally in 2002 to 2005, I wanted to write this down to see if, in fact, I could tell a story that to explain what I had sort of come to know about nutrition. I did it with my son, who at the time was in theater. He was an actor in Chicago, actually a good writer. Got him to come back because he wanted to earn a little money and wasn't making any money in acting. But he got involved with me and got really enthused about all this, decided to go to medical school, went back to medical school, got his degree. He's now just 3 months short of his residency in family medicine, by the way. And he's really come on board, so we now are sharing some lectures and things like this. I do have to give him credit where. But when we did that book from 2002 to 2005, I went back to the literature to see if this stuff we're learning about cancer and maybe heart disease and things like that, are there other diseases? Is there something in the literature we hadn't, paid attention to over the years? Here's a list. Look at that. I mean, obviously, some of these are pretty serious. They have mortality figures attached to them. Some of them are nuisance kinds of things, you might argue. But in any case, here's what the literature shows, except for these two right here. There's not enough published information on these two yet. But anyhow, the rest of them, there's actually published data showing that a whole food, plant-based diet prevents, suspends, and or cures all. That's an exciting proposition. We're not talking about a single agent doing something that might be of importance and interesting. This is something that has a broad reach across a whole lot of diseases. And it doesn't involve one thing, for sure. It involves countless things in plant-based foods that obviously are working together, sort of like a symphony. So we got another lesson here. The whole food plant-based diet effect is broad. Now, I want to just kind of finish up on something that came about actually in 1990, 91, I guess it was, that my friend, my good friend now, Dr. Caldwell Esselstyn at Cleveland Clinic, he did something on this. Our work and was actually featured as a cover story in the science section of the New York Times when it first came out, our China data itself. It came to the attention of Dr. Esselstyn at Cleveland Clinic, a very distinguished surgeon there, had been there for many years. In fact, he has a very distinguished medical background, quite frankly. He and his family, both his wife's family too. Dr. Esselstyn had seen this. He called me up and said, you know what, I'm working on some heart patients here, and I'm seeing some results. And he wanted me to come into a conference in Tucson, Arizona to join him because he thought what we were finding in China was similar to what he thought he was seeing. So we went there. I learned about Dr. Esselstyn's stuff at the time. It's really become quite dramatic. Namely, Dr. Esselstyn, on his own volition, as I say, he had his own reasons. We weren't talking to each other. It was his thing. He started out with 18 seriously ill heart patients and decided, I want to put them on a plant-based diet. He actually, in the beginning, included some dairy. And when we talked, he took them off the dairy real quick. But In any case, he left them on a whole food plant-based diet. And he, in the beginning, he started out, had a little load of statins, lovastatin, just to play on the safe side. He didn't want to get in trouble here on this thing, so he had that. Later, he was to learn that the statins did nothing of what he's seeing here. I'll show you the evidence for that in a moment. It was actually just a dietary effect. So this thing, they started out 18 patients. They had 49 coronary events in the 8 years prior to the study. MI, angioplasty, bypass surgery, those all called events. And they had had a lot of activity. 5 of them had been told by their favorite cardiologists that time was up, couldn't do anything more for them. And so here they are, 49 in the beginning. They went from 49 coronary events in the previous 8 years to 0 over the next 12 years. This is the published stuff. Now, this is pretty remarkable. I think you would agree. Going from that level of activity to this, it turns out now these people have lived for 27 years since that study was started. Not one person has died of a coronary event during that period of time. So he allows himself to say that he cures heart disease, and he can. He really can by diet alone. And it's really remarkable, and it's fast, and I'll show you some more information that he's since subsequently developed that hasn't yet been published. Dr. Esselstyn, in case any of you know, how many of you have heard him speak? Anybody not here? One person. Well, he's had a very bad bicycle accident, by the way, about 6 weeks ago, and nearly did himself in, but in any case, he's recovering. He has this new information. He told me that I could show this. He retired same time I did from at Cleveland Clinic, as I did from Cornell, more or less. And but he continued to look at attend to his patients who would come to see him. Since then, he's had, or up until a couple of years ago, he had attended to something like 200 and some patients who had serious problems, and he wanted to put them on this, and he was coaching them. So he and his wife gets together, and he would take 5 to 10 people at a time, and spend 5 hours with them. That's all. Told them what they should do. Whole food plant-based diet, and here's how you do it, kind of thing. So then, a couple of years ago, he went back and called them up again, see how many people he could find, and find out, in fact, had they stayed with us, and how were they doing? He hadn't been speaking to them in the meanwhile. So that's what accounts for this 2 to 7 years later when he went back and so I was asking, what's going on? It turns out, wait a minute, yeah, so when he had, I'm sorry, he found 196 heart patients that he had worked with. It turns out that 177 of those 196 continued to comply and stay on this diet for those between 2 and 7 years. That's a compliance rate of 89%. And I know that many of you might find this really surprising, but the key there is that he believes what he really believes is he's convincing. Obviously, these are reasonably vulnerable people. They're looking for support like this. And so but still, 89% is a pretty good record. So now we can look at the ones who are compliant with the diet and those that are not. And it turns out those who are compliant with the diet, only 0.4%, one person out of 177 had a heart event. There's actually a friend of mine who went to China and he actually strayed from the diet a bit. 0.4% while they're on the diet. The non-compliant, 67%. I think you would agree that's a pretty big difference right there. And in the meanwhile, he left them under the control of their personal physicians, of course. Statins were used by many, I think most. He didn't want to disturb that. He obviously left that to the decision of the personal physician and the individual, obviously. Said you can do what you wish. Well, it turns out, over that course of that time, the ones who are getting better on the plant-based diets, this is typical. Statin use goes down pretty fast. A lot of people were off statins. So clearly, the compliant ones were the ones using much less statins, much less exposure. The ones who are still staying on their statins, they're the ones that got to 67% heart return rate. So this is another bit of evidence to suggest that when you compare statin use versus dietary use, you see the pretty remarkable differences. Okay, now this may be the most important slide I think I want to bring to your attention, especially given all of you, in the primary care sort of business. We've been told by our grandmothers and our mothers for, generations, that we should eat our vegetables. I don't know where they got that from, but we've generally thought that vegetables are a pretty good deal. We should be eating more of that kind of thing. But all for the purpose, I think you would agree, of preventing some future disease. Thus, it gets in the rubric of preventive medicine. Eat this way, folks, and you won't get that future disease. That's not terribly motivating, I think, to get people to make changes, especially young people. Who cares about that? They think, I'll cover that when we get to it, kind of thing. Well, so I want to suggest that we should take nutrition out of that category of preventive medicine. It doesn't belong there. Neither is it should be called alternative medicine. It's not alternative medicine. It's not preventive medicine. Because what we're now finding is that when you take a group of people, and I've done this with my son, we've done a few others, you take a group of people, you switch them over to this diet, the results you get are amazing from across the board in terms of cholesterol drop, weight dropping, sugar drops, triglycerides go down, blood pressures are generally brought under control if they've got a problem on that line. That's called, in my book, treatment. We're using diet to treat, not just to prevent, but to actually treat. And I think that's a dynamic, a thought, in fact, that, oops, I went too far. Why did it do that? I don't like to have my story jump ahead of me. Oh gosh, I can't get it there. Okay, let's just stick with it. The effect is very broad in its scope, all kinds of diseases and pains and all that kind of stuff that we saw before. It's very quick acting. You can see these kind of changes in days to weeks. It really is pretty remarkable. Most of the people who do this, let's call it vital too. I mean, we're talking about people who, in fact, have been told enough more to do with you, and all of a sudden they discover they can do something after all. And of course, this all comes along with basically no side effects when compared to drugs. So I'm going to suggest we have something here. It's one of the great food secrets. It has to do with nutrition and what it could do, not just prevention, but also in the case of treatment. It truly is remarkable. And I say we got another. That was lesson. Nutrition therapy, I would suggest, is more powerful and broad in scope and more rapidly acting than drug therapy. Here's another lesson, an old one, 2,500 years ago. Hippocrates said this, let food be thy medicine and medicine be thy food. I think he knew what he was talking about. So I think what we're seeing here is, in fact, what Hippocrates, from a different perspective, saw what he saw. I don't know what this, sorry about this. Let's see, I'm going to have to go. Okay, just a couple more slides. Nutrition, I didn't get to put this in here, but here's the statement. Nutrition is not, we tend to study nutrition as a reductionist science. We study it one nutrient at a time, one mechanism at a time, one outcome at a time. That's not nutrition. That's pharmacology. We know, for example, right now that nutrient supplements don't work. They really don't work. We've had lots of studies now in the last 30 years, lots of trials. They really are not working. If in fact anything, they cause problems. They can actually increase disease risk. Just normal, just household old nutrients. So it's not, that's what nutrition has been as it can't be. We got to think of nutrition in a more holistic way. And one way to spell that word is HOLISTIC, and that's what the dictionary does. And I've actually just finished writing a second book called Whole, going back and looking at this question from a philosophical, historical, economic, and scientific point of view. And nutrition is a holistic science, but not spelled with HOL. That's disturbing to some people, I think you can recognize. This is where science and religion sort of conflict. And for some reason, that word holistic, that concept was spelled with HOL, when it should not have been. And so if you put the W back in where it belongs, which is what holistic really means, then we have a new description for nutrition. What it can do, it's the whole, not the parts. So the whole is greater than the sum of its parts. And again, a very old idea that goes back to the ancient Greeks. I better see if I can do this. Okay, so I think this particular description here was published in the New York Times, not for this purpose, but I thought it was kind of apt for what I'm talking about. That, in my field, biomedical research, let me just mention this. We tend to work on one thing at a time, and we give no attention to nutrition. I kind of stuck mine under the tent in a little ways accidentally, because I was interested in cancer. So we got lots of generous funding for many, many years from NCI. You know, of the 28 institutes at NIH that does biomedical research, 28, heart disease, cancer, so forth and so on, of the 28, there's not one called the Institute of Nutrition. Not one. It's been cleaned from the slate. So we're not really doing research in this field. And I've really been quite active in this, trying to make this argument. It doesn't work. And of course, in the medical practice field too, I think you would agree. My experience that medical schools really don't teach nutrition. Because the model there is a reductionist model, just like is in my field. We tend to work one thing at a time. And we run into problems. We get lots of confusion. We get side effects. We get this, we get that. Whereas nutrition, in contrast, if we stand back and just look at it from a holistic perspective, is very different. And the results that we get, of course, have been missed. That's why I say it's kind of a mismatch in a way. So I end on this here, or no, one more, I guess. The book on the left is one my son and I did. That's coming out. Our daughter did this cookbook, and that's the book that I'm really kind of excited to have. This is coming out in May, and I'm quite excited to introduce this idea because I think, for me at least, it helps me really understand why the public is so confused about nutrition. It helps also to advance the idea that we should take it more seriously. And I'll finish on this note here. I was teaching a course in this at Cornell for a few years before retirement, a couple years after. Eventually it was put online, and right now our foundation actually has this course running in collaboration or partnership with the arm of Cornell that does online courses. We're quite excited about this. It's been very successful. We've only been doing it for 3 or 4 years. We offer 30 Category 1 CME credits or CEU, however you look at it, for people to get some credit for this. And it turns out that at Cornell, Cornell's ranked as one of the top 10 online programs in the country, and they got something like 200 courses from business to whatever. Ours is number 1 of the 200 in terms of the interest. So I'm just telling you that because the interest in this field is just escalating rapidly. And I think that it's doing so because as people try it, as they try it and do it right, it's really important, you've got to do it right. And do it right, the results are really spectacular. I think I've met a couple of individuals here that always meet some people here want to tell me about that kind of thing. So anyhow, I think it's a very exciting future for nutrition, and I would suggest for your thinking that if you can get that into the medical practice system, I think we'd all gain by it. Thank you very much. Yeah, take a couple
questions.
Yeah.
From the audience.
Right. Yes, sir.
First of all, you don't know this, but I became a vegan in part because of you and Dr. Esselstyn. So, in a sense, you're my hero. And somebody who influences my life today more than many other people. But I have 3 questions that I want to ask you. Number 1, the method that you were describing earlier was about isolating one particular protein and then generalizing it to a bit. And then you turn around as an argument to tell us you have to look at the holistic part.
Right.
So you're using an argument from one side,
Right.
trying to maybe convince people who understand their argument, but I don't see how this works.
You don't see it's an excellent question. I'm really glad.
Let me ask you 3
Oh, okay.
questions and then please. The issue of eating healthy versus living. When I became vegan, and I talked to Dr. Schwartz, my housekeeper said, you eat like I used to eat when I was poor in Honduras. So I went next time to Whole Foods and I bought whatever I buy for the week and it was $300. She cannot afford $300. Maybe in those times she can afford $300 to eat cheaper food that she grew herself, but not today. So where will we balance that? We have a family can eat hamburgers and for 99 cents a piece and live shorter life, but they eat. And
maybe before I forget all your questions, let me answer the first 2, okay? The first one, you're saying that we use the reductionist method, one protein, one nutrient at that time. And of course we did. That's exactly what we did. Keep in mind, I was working within the reductionist paradigm. That's what we got funded for. I had I shouldn't say I have no interest, but I had no intent of going to where I went to. I simply was using reductionist research, published the stuff that way. It was handsomely funded, kept getting renewed, all reductionists. One nutrient, you're right. So then we went, okay, let's ask some more about some other nutrients. True. Let's ask some things about some other diseases. And the principles that I was talking about, reversal and nutrition controlling genes, multi-mechanisms, and some more, you put that together, all of a sudden I realized I was working in the wrong world. I was using reductionist science, running into questions concerning a lot of confusion, heresies, and all that stuff, and say there's something more here, because when you look at it collectively, all this reductionist stuff, you suddenly realize, for me, I'm looking at the parts that became the whole. Or at least I thought. So when we wrote the book, for example, I'm still, even at that point, I'm writing a book to say, hey, can I explain this to myself? So we wrote down all the, what we did and research of others and stuff like this, wrote the book, and told the reader just the question I was concerned about. So the reader, you don't have to believe me, just try it. I mean, if we had evidence, I think you would agree, it's evidence for sure, right? And so I said, just try it. Since then, now going on 9 years ago, it's being tried, and it's remarkable.
No,
so
I
it's a question
don't know that it's remarkable because it's remarkable with me. My
okay, it happened to you.
Down completely, went from 260 to 180.
Right.
With no medication. I was taking medication, no medication. I lost 25 pounds. I maintained exactly the same weight. It's not easy. It's a very difficult diet.
Not always true, but go ahead, yeah.
Because the diet that Esselstyn recommends is oil-free, and that's the hardest thing to do. And oil-free also because of isolation is part of olive oil being a good reduction for cholesterol, which happens to be that. But I have one more point. First of all, you've shown in the slide that you can cure type 1 diabetes, and I suggest that that's...
No, wait. You didn't look at the rest of the slide. I said prevents, suspends, and/or cures, right?
It cures all.
Cures. Yeah, maybe the words aren't right. I mean, some of those things were just...
type 1 diabetes.
Type 1 diabetes, what I'm referring to there, that one, you picked the one where maybe there's an overstatement there possibly.
Well,
but this is where
I
James...
have someone with type 1 diabetes. So
okay,
that's...
let me say it. James Anderson at University of Kentucky, some years ago, ran through a study where he had both type 1s and type 2s. And he moved into a sort of more plant-based diet, but with fiber supplementation, usually in the form of foods. And he was able to show fairly readily, and now it's been done a number of times, that the dosing, the medication can be reduced. I couldn't believe this.
Oh, sure.
Reduced by a half, 2/3. Yeah, so in other words, the effect on type 1s is working in the right direction, not to its completion, truly. And reversal, no. Although, now there's some evidence that, we can restore some insulin synthesizing activity, with time. That's not altogether gone. Pardon?
That's for type 2. Give me just the last question.
You're taking up all the time. There are a lot of people here that may have some other questions.
Yeah, we can talk about that.
We've got time for about 2 or 3 more questions. Anybody else have a question?
Yes.
Yeah, being so bad to eat animal-based proteins, what is, in your opinion, the natural selection advantage of eating animal-based proteins? If there is some advantage of eating that,
Are you asking us?
Have selected that?
Are you asking, if I can understand you right, is there some characteristic about animal-based protein that gives it that property?
In evolution, I mean.
In evolutionary times? I don't know whether evolutionary times I don't think I can speak to that because that's a different kind of question, but if you compare animal and plant-based animal and plant-based proteins, their amino acid composition is different. And all animal-based proteins tend to have a little more of the sulfurs that lead to a little more acidic metabolic acidosis. So you're getting a little drop in the pH with animal proteins compared to plant proteins. That can be very significant, especially when you think of the logarithmic differences of pH. And then just to drop a little bit, you can begin to influence enzymes. One enzyme of which has to do with the activation of vitamin D, the 125-hydroxys in the liver, to form the 125-dihydroxy. That's really the business end. So when you drop the pH a bit, you're running into some questions concerning, some compromise of the body's ability to deal with things. That's the acidic properties of animal-based proteins. There's some other things that have been noted too, and that has to do, it's been described by the Japanese some years ago as a ratio of, let's say, arginine to lysine. They seem to see animal-based proteins doing one thing, plant-based proteins doing something different depending on the arginine to lysine ratio, the two different essential amino acids. That hasn't been clarified as exactly which one is doing what. From my perspective, and this actually went all the way back to my doctoral dissertation at least, animal-based proteins all have this aggregate effect or function of a high biological value. That's why they're called high quality, which means they, as a group, they tend to promote faster rate of growth, as a group, compared to plant-based proteins. And the reason for that is because animal-based proteins that have amino acid compositions more nearly like what we need. We're animals after all, too. So the efficiency of utilization of the animal proteins is greater for animal-based proteins, therefore stimulating more growth. And we just happen to see that the growth factors go up with that. We happen to see other things go with it. So the best I can answer your question, I think, is just recognizing that animal-based proteins do that. It's been described as possibly related to amino acid composition in some ways. We see the results, and you can make of it what you like. I don't know.
And what about the when we are growing during development? For example, there's studies showing that milk-based diets are very helpful for the growth and for increase the ICI of the
Right.
kids, and also you grow more.
Yeah, okay. Let me take that question just at this point here. Yes, for many years, we judged animal proteins as being superior because they promoted more rapid growth rate. People who are raising pigs and animals like that would love it because, you know, they make more money. I mean, I came to the farm, I know that for a fact, and I used to teach livestock feeding. Actually, matter of fact, I was a graduate student. So the animal-based proteins will stimulate a little more rapid growth. In humans, sure enough, the best example I can give to you is some research we got out of China looking at breast cancer etiology. Age at menarche in women, the beginning of the reproductive life. Age at menarche in women in this country is somewhere around 10, 11 years, I think. Some people say it's lower. The age at which the reproductive life starts is closely linked to the rate of growth, body growth. The more rapid the growth, the earlier the age at menarche. In the American population, it's around, when we were doing it, it's around 11 years, I hear, 10, 11 years. In China, the average age of menarche was 17 years. On a much lower protein diet, a little slower growth during those reproductive years. And as soon as the age of menarche, as soon as the menarche starts, then the woman is synthesizing more estrogen. And during the reproductive life, they stay on a fairly high level, about 2/3 higher in Western women than in rural Chinese women. And a higher level of estrogen tends to associate quite nicely with breast cancer from independent studies. In Western women and Chinese women, the age of menopause in China was 48 years average. The age of menopause in the American was 52 years. So a woman has a reproductive life about 9 years longer and has a general circulation level of estrogen about, what's that, about 50% higher. The total exposure to estrogen for the American woman during reproductive life is about 5-fold higher, total exposure. It turns out that's the difference in breast cancer rates too. And so you go back and look at some of the data. So breast cancer, one of the best metrics for measuring breast cancer risk is to calculate in some way total exposure to estrogen. All coming back to this, is your question. All of that occurs with rapid rate of growth. So I say the most rapid rate of growth is not the optimum rate of growth. Therefore, the presumption we made for historically that protein is better because it increases rapid rate, no, it doesn't. You can take vegans really fed well. The ultimate height that they get, attained height for adults, is really very good. I can speak about 2 of our grandchildren, as a matter of fact, who started out from 0, never had a piece of meat in their mouth, didn't have any dairy, nothing. People say, what are you doing? It's kind of crazy. Their father was about 5'11", Their mother is about 5'6", 5'7". They've grown up. They've been outstanding athletes. One of them was in North Carolina, was on the first team running for on the first team soccer. One of them is between 6'3" and 6'4". The other's about 6'2". Now, there's cases you say, oh, that's silly, or some silly old man talking about his grandsons or something. But the point is, we see that. And there's very few kids that have this opportunity of going into the business, just refusing to have any dairy, no, none of that, and then ended up with that kind of health. The key is doing it right. Most vegans really don't do it right. And I don't use the vegan and vegetarian words because I think they're unfortunately become a little bit pejorative almost. Because vegetarians, 90% of the vegetarians are still using dairy. The nutrient composition of their diet is not that better. Vegans, I don't particularly like that word vegans either because the motivation there for vegans was primarily ideological, animal rights and all that kind of thing. It's fine and dandy, it's fine for people to do that. That's not where I came from. Vegans tend to turn, by avoiding all animal-based foods, they tend to use quite a lot of processed foods. So the average fat content of a vegan diet is still pretty high. So I don't see the vegan diet being very good, to be honest about it. That's why I like the word whole plant-based foods. Sorry for that long answer, but I don't know how to...
Thank you. We probably could spend several hours and probably days. I have some exciting news for you. We actually have a raffle going on. I wasn't aware when we started. And we have some of your books to go away. So why don't you do the honors? Reach in and pull out 5 or 10?
10.
So 1653273. Up there in the back? Okay.
There you go. Come down and get one of Dr. Campbell's books.
Okay.
But you haven't done this before.
No, I haven't, actually. 1653274. Who was that? 1653274. Going. Now we have to do that one again. 1653284.
Yes.
Oh, over here.
So 3, 2.
Yeah, okay.
1653287.
Here you go. Thank you.
7678.
1653287.
78.
So let's just do the last 4 digits. 3310.
3316.
Nice.
Thank you.
So 3276.
3320.
3339.
3340.
3327.
3329. Last one.
This is really a lucky number here. 3333.